Previously, we have defined the degree of a map of spheres. A continuous map f from Sn to itself always induces a map on homology group. Now for Sn, its n homology group with coefficient in z are isomorphic to z. So this map here must correspond to multiplication. That integer is then called the degree of f. In this video, we're gonna first prove some easy properties of degree, and then in the next video, we're gonna use this to prove very interesting stuff. Let's start with some super trivial property. Why is the degree of the identity equal to 1? Well, observe that if f is the identity, then the induced map on homology group is also identity, i.e. it's just a map multiplication by 1, so the degree of f must be 1. Now similarly easy is the property that the degree of a composition is just gonna be equal to product of degree. This is because by functoriality of homology theory, we know that this composition is just gonna be the induced map of f composed with g. Thus this corresponding map on the integer must be equal to the degree of the composition, and thus the degree of the composition must be equal to this product. Next step, why is reflection of degree minus 1? This is because this homology group is generated by the class of n minus s, where the n is the north hemisphere and s is the south hemisphere. And we know that reflection just interchanges these two hemispheres, so this is mapped to s minus n. In particular, this induced map is given by multiplication by minus 1. That is why degree of reflection is minus 1. Now finally, why is the degree of the antipodal map equals to minus 1 to the n plus 1? Well, this just comes from the fact that the antipodal map is just obtained by composing a bunch of reflection. For example, let's look at the case when n is equal to 1. To get the antipodal point of P, we could use two reflection, one across the y-axis and one across the x-axis. In general, the antipodal point on an n-sphere is always gonna be the composition of n plus 1 reflection, and thus the degree of antipodal is equal to minus 1 to the n plus 1. Up next, we're gonna use these properties to prove some interesting stuff.